Hello guys, welcome to another video on daily algorithm challenge, and in this video we want to solve the problem binary tree in order traversal. So let us read the context. Can you write a function to traverse a binary tree in order and print out the value of each node as it passes? Okay, so they're giving us this example and they say the example output is 465 since there is no left child for 4 and 6 is visited in order before 5. What they are telling us now that if we look at this example, in binary tree, the left part of the tree, the left child has more priority than the right child. We are expected to visit the left child first, but since there is no left child, so we are going to the root. Then when we go to the root, then we'll visit this, but this will not be counted. Then we'll visit this and count this, then go back and visit 5. Okay, so supposing we have one item at this part. We have one item. Let me say, for example, we have 2 at this side. So we are going to have 2 first, followed by 4, followed by 6, and followed by 5. Then if we have another item here, let me say, for example, we have like let me say, for example, we have like 8. So guys, so let me say, for example, we have this binary tree. So we are going to have 2 first. We're going to visit 2, then 4, then 6, then 5, then lastly we'll visit 8. Okay, so that is how binary tree works. All right, let me clear my screen. Okay, follow up is you likely get the recursive solution first. Could you do it iteratively? Okay, so I'm going to try and solve the two, but I'm going to solve the recursive one first. So guys, let us see in action. So I'm going to copy this content and go to my VS Code, and my VS Code, I'm going to create a file, binary tree traversal.py. Okay, so I'm going to paste the content I have, then I want to give space. I want to give a space for the unit test. Okay, good. All right, so this is where we are going to write our solution. So let me do the recursive example. So what I'm going to do is I'm going to check if the root, right? So if the root is not known, okay, so the following action will take place. Okay, sorry about that. So let me set my result first, which is my final result. My final result is going to be an array, so I want to return that array. Okay, so let me just assign my final result. This is going to be my final result. Okay, so if the root is not known, so I want to use the result dot extend. So I'm going to use the extend. Then what am I extending? I'm going to extend in order. This is recursive call. So this is going to be in order of the root element dot left. Okay, so the left has more higher priority. Okay, note this left, we already have it here. You can see this is it here. Okay, it is a property of the class node, or it's property of the node class. Okay, so and the extend keyword, it accepts an iteratable. So this is going to return an iteratable, and I'm going to put that in this result. So the next thing I want to do is I'm going to set I'm going to append the value to my result. So I'm going to do root dot value. Okay, value is also the property of the node class. So the next thing I will do is result dot extend. I'm also going to use the extend keyword to extend the in order of the right side this time. So it's going to be root dot right. Okay, so at this stage I just want to return my result. Okay, so this part is going to take care and collect all the value, and I'm going to return the result. So I believe this is going to work. So let me run this code. Let me clear my console first. I'm going to run. Excellent. You can see we passed the first test, we passed the second test, and we passed the third test. Okay, so let me copy this. I'm going to copy this and paste it on the platform, and I'm going to run. I'm expecting the results. Excellent. So this works. All right. So before going to the next solution, we need to explore the time and space complexity for this code. So guys, this is a recursive call, and the time complexity for recursive call is O of n. Okay. So let me write that here. So I think, okay, let me put that here. Let me put that here. So this is going to be O of n time. And the space complexity, you can see we are storing every value in the node. So this is going to be O of n time, O of n space rather. Okay guys, so now let us look at the other solution. So I'm going to comment out this. The only thing I'm going to leave is the result I have declared. Okay, so let me bring this down here, close to here. Okay, so for this solution, because now we want to work on the iterative parts. Okay, where is it? So yeah, so it said, could you do it iteratively? Okay, so now we want to use iteration to solve this problem. So I'm going to use stack to solve this problem. Okay, so I am going to declare my stack. My stack has been declared. Then I'm going to set a variable current which hold the current node. Okay, so the current is going to be the root. Okay, so I'm going to use a while loop. So while the current is not known, while the current is not known, okay, or I have an item in stack. Okay, so then this is two condition. Okay, why the current node is not known and there is an item in the stack. Okay, so I want to do some loop. Okay, so then why the current is not known. Okay, so I want to add that node to my stack. So I'm going to do stack dot append. Okay, this is it. Dot append current. Okay, so the current will be added to the stack. And so in order not to end in infinite loop, so what I'm going to do, I'm going to set the current is equals to the current dot left. Okay, so no, this should be left. Okay, so next, the next thing I want to do is inside this top while condition. No, we have two while condition, not the inner one but the outer while. So I am also going to set current will be equal to the current in the stack. Okay, so you're gonna the last item in the stack is going to be my current. Okay, so while we've taken care of the left side, we want to take care of the right side. So the next thing I will do is my results. I'm going to append the current value of the node, so which is going to be current dot value. Next, we should move into the right side. Okay, so the current is going to be current dot right. Okay, so this is going to give me all the item in the binary tree. So let us run this and see if it will work. Excellent. This works. I'm going to copy this and go to the platform. Okay, so I'm going to run this. Waiting for the results. Excellent. So this works. So now, what is the time and space for this? So if we look at this very solution, so we're using a while loop to loop at every item. So this is O of n time. This is O of n time. And for the space complexity, since every item is being stored, we should have the big O of n time. I can see they said expected space complexity is O of 1. I am wondering how a user is going to achieve this, because I think this is kind of complicated, because first of all they said print out. If they are asking us to print it out, definitely we don't need the result. Okay, all we need to do is to take the result out. We're going to take the result out and use the print statement. We're going to print that value here and print that value here. Then we can achieve O of 1 constant time. But however, they mentioned print here. They said we should print the results here, and if we go further, they are saying this is the output. So we are kind of wondering. And if you look at the test, you can see the expected value is an array. Okay, so I am wondering how is that possible for someone to print out, for someone to have an algorithm that has O of 1 space. It might be possible if you find a way to solve this problem in O of 1 constant space. Please, you can drop a link to your code in the comment section so I can learn from you. So all right guys, thank you very much for watching. Thank you very much for watching this solution. Thank you. I'm going to see you in another video.